All right, today we're going to keep talking about the domain and range of discrete functions and continuous functions. So when we take a look right here at our first two examples, it says find the domain and range of the coordinates and decide whether it is a function. So this is kind of some review. Feel free to pause the video if you'd like to take a minute and decide the domain and range and then determine whether it's a function. Okay, so when we look at number one, we're going to look at our x coordinates, right, to determine the domain. Remember, each coordinate has x, y, right, x, y. So if we're looking, we like to write our coordinates in ascending order. That means from least to greatest. We see we have -5, we have 0, and we have 2. And for our range, we have -3, 6, 7, and 8. And now to determine if it's a function, we have to look and see whether the x's repeat, right? So looks like it repeats right here. -5 goes with 8 and it goes with 6. So here we go. We say, is it a function? No. All right. Now, when we come here to the second example, the domain starts with -5, then -1, 0, and that's it. So that's our domain. Our range starts with -5. Then we go up to 4.5, 6.8, and finally, we're running out of room here, 7. Now, is it a function? It is not a function because 0 goes with -5 and 7. All right. So then we're asked to find the domain and range of these graphs down here. But first, we need to decide whether or not it is discrete or continuous, and then decide whether the graph is a function using the vertical line test. So looking at this first example, this is a little bit of review, right, from Wednesday. Is this discrete or continuous here? All right. What about here? Discrete or continuous? What about here? Discrete or continuous? All right. So let's start with that. All right. Looking at number 3, remember to determine our domain, we're just looking at each point, right, to determine the domain. So maybe we have, looking here, this is our origin right here. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3. If it helps to label, do that. All right. So to determine our domain, remember we start from least to greatest. So we're going to start down here. What is the x value of this point? Actually, we're going to start here. I'm sorry, guys. We're starting here because the x value is 0. X value here is 1, 2, 3, then 4. So we go in ascending order. So this is 0, 1, 2, 3, 4. And for the range, we start here. And then we're going to go this way. Because right here, our range is 0. Right? Right here, it's 2. Here, it's 4, 6, and 8. So that's what we're going to write. 0, 2, 4, 6, 8. Now, is it a function? We're trying the vertical line test. We're drawing this vertical line to see if the points cross this vertical line in more than one spot, each vertical line in more than one spot. And it looks like the answer is no. So yes, it is a function. All right. For our domain here, this is a continuous function, right? Remember, continuous functions, the domain starts with the smallest x value and goes to the largest x value. So if we want to, we can determine what these points are. All right, so note that this point right here is 1, 2, 3, 4, 5, 6, 7, 8. So this point is 0, 8, while this point right here is 4, 0. All right, notice how the smallest x value between the two is 0. So we're going to write 0 here. Our largest x value is 4. Remember, we're talking about the domain, so x goes in the middle, and then we write less than or equal to because of the closed endpoints. And all this means is that our domain x is in between 0 and 4. All right? And for our range, we're going to look at our y's. Remember, we look to our smallest y value, which is 0, and our largest y value, which is 8. Remember, we're talking about y, the range, less than or equal to. All right, it's always less than or equal to. And we're just saying that our range, y, is in between 0 and 8. And yes, it is a function because if we draw vertical lines, we're going to see that the graph does not touch the vertical line more than once. All right, so yes, this is a function. All right, now to look at this next continuous part. All right, we have here this continuous graph, but notice the endpoints have arrows, right? Remember, to find the domain, we're looking for our smallest x value, right? Smallest x value. But if this doesn't end, it's not an endpoint, then there is no smallest x value. So we write negative infinity. And this also up here is an arrow, so there's no largest x value. So we write positive infinity. And we do the same for the range because there is no lowest or highest y value. Remember, domain deals with x, so we put x, and then it's not a less than or equal to because this is not a closed endpoint, right? This is an open endpoint with the arrow. So we're going to write strictly less than because we cannot reach negative infinity or positive infinity. And I made a mistake here, guys, and wrote negative there. All right, so our range goes from negative infinity to positive infinity. We're going to put y since we're dealing with range, and then strictly less than. Okay? And is it a function? Yes, it is. And we already said we know we're dealing with continuous. So what I want you to do is take a moment to try 6 through 8, and we'll go through it in class. A hint I'm going to give you guys before is that this is an open endpoint while this is a closed endpoint. So what does that mean? Well, when we start looking at our domain, right? It's going to be open here, closed here. That just means when we're talking about our symbols, it's going to be less than or equal to for this closed symbol. And then for this open symbol, it's going to be strictly less than. Strictly less than, because we're not including the 0.6. All right, now you guys try.